Here we've got group 7, halogens or halogens. So inside that group, so it's very important to remember the name halogens. We've got fluorine, chlorine, bromine, iodine, and astatine. That's as you go down. So fluorine at the top, chlorine. Now they hang out in pairs. So fluorine as a single atom doesn't happen. It combines with another fluorine. So you've always got two of them. So it's always F2. Chlorine, bromine, iodine, and astatine are the same because they all act in the same way. So it's always Cl2 for chlorine, Br2 for bromine, I2 for iodine, and so on. They hang out in pairs. Now, they are less and less reactive as you go down the group. So fluorine, obviously being at the top, is the most powerful, which by that I mean the most reactive. Astatine is the least reactive because that's down at the bottom, and the atoms, as you go down the group, they get bigger, obviously, because they have more stuff in them. So they have more protons, more neutrons, and more electrons as you go down the group, so the atoms get bigger and bigger. So fluorine, the most reactive, then chlorine, then bromine, then iodine, then astatine. It's very important to remember that the strongest is at the top, and they go down in steps. So chlorine is not as strong as fluorine, but it is stronger than bromine, iodine, and astatine. Now, as you go down the group, they become darker in colour. So fluorine, not fluoring, is yellow and it is a gas. So these things are important. Chlorine is a yellowy green, more green than yellow, and is also a gas. Bromine, or bromine, depending where you're from, is brown and orange and a liquid, and astatine is grey and a solid. So as you go down the group, they change from gases to liquids to solids, and they become darker. Yellow, green, orange, grey. Now, all of these things are bacteria killers. They are used for killing stuff. They're used in cleaning things. So fluorine for your teeth, chlorine in swimming pools, iodine is that yellow stuff you put on your skin before operations. They all kill bacteria. So they're very, very, very potent. Now, the reason for this is that they steal electrons off stuff. And if you steal electrons off things, you destroy things. So most, in fact, all reactions, when you get down to the basics, are just how electrons move or are stolen or given away. And these fellas in group 7, they nick electrons off stuff really, really, really easily, particularly fluorine and chlorine. So obviously the smaller the atom in group 7, the more reactive they are, and fluorine is the smallest, then chlorine, and so on. So as you go down the group, the atoms get bigger, but the smallest ones are the most potent. Now, the reason that they can steal things better is because their nucleus, which contains all the protons and neutrons, are very close to the surface, and they can steal electrons off other people much, much more easily. So that is the reason why you go down the group. They are less and less reactive. Now, I suppose one of the bigger parts that comes up in things is that they can bully each other in terms of something that we call displacement reactions, but they just nick each other's stuff. Fluorine is the strongest, so it can nick anything off the others. Chlorine can nick anything off all of the others except fluorine. So probably better as an example. So if there is potassium bromide, which is potassium metal and bromine joined together, if we mix that in with fluorine, because fluorine is stronger than bromine, it's higher up in that group, it will steal everything that bromine's got. So it nicks all of the potassium off the bromine. And what you get is, you get potassium fluoride, and within that solution, an orange stuff will suddenly appear, and that is the bromine that has been kicked out and has had its potassium removed by the fluorine. So chlorine will still steal anything off all of the others except fluorine, because fluorine is stronger, and so on. So it means that potassium fluorides and an orange liquid appear, which is the bromine. And sometimes, one of the last questions comes up every couple of years, they will ask what colour damp litmus paper goes when in chlorine gas. And the answer is white, because chlorine gas will bleach it. And that is that.